Welcome to this explainer. Today we're diving into the fascinating invisible engine that actually keeps our favorite apps fast, secure, and online. If you've ever wondered how the internet manages to hold itself together behind the scenes, well, you are in the exact right place. Today we are talking all about Nginx.
The answer to this question might actually surprise you. It's usually not about writing better code. You could write the most beautiful, flawless application code in the entire world, but if you expose it directly to the open internet, it's going to struggle. Surviving massive traffic is almost always about putting the right gateway at your front door.
To see how this works, we're going to explore the 5 distinct capabilities of Nginx, basically treating it like the ultimate digital multi-tool. We'll be looking at the blueprint, the filing cabinet, the security guard, the traffic cop, and finally, the armored car. Let's get right into it.
Starting off with number 1, the blueprint, or building for scale.
So, before Nginx came along, the standard was software like Apache, which relies on a thread-based architecture. Imagine having to hire a brand new, dedicated employee every single time a customer walks into your store. Sounds exhausting, right? It gets heavy, incredibly fast. But Nginx, it uses an event-driven model. It acts more like one genius manager who seamlessly juggles thousands of requests at the exact same time without breaking a sweat, dealing with events as they actually happen, rather than spawning heavy new processes.
What this really means is that this lightweight design lets your servers do exponentially more work with significantly less memory. Because its memory footprint is so unbelievably low, it has literally become the absolute go-to standard for modern cloud platforms and containerized environments like Kubernetes. It just effortlessly handles massive crowds of concurrent users with blazing fast delivery.
Moving on to our second tool, the filing cabinet. This is all about the fast web server. Now, before we get into the really fancy routing or security features, we got to understand its foundational day job. A web server is simply software designed to find and deliver static files. Think about it. When you load up a basic web page, you're mostly just downloading static text, styles, and images. Nginx is exceptionally good at just instantly handing those files straight over to the user.
Here's how that flow actually works in practice. A user requests your website over the standard HTTP port, which is port 80. Nginx catches that request, instantly checks its internal configuration rules, peeks into a specific default folder on your server, grabs the exact document asked for, and boom, serves it right back to the browser. It's a beautifully seamless flow. It literally acts like an ultra-efficient filing cabinet, pulling the perfect file the split second it is requested.
All right, number 3, the security guard, also known as the reverse proxy. So this brings up a pretty massive problem. What happens if you have a dynamic backend application, say a Node.js app that's actively processing data? If you just stick that app directly on the open internet and give out the direct address, it is incredibly vulnerable. Hackers can bombard it, they can send thousands of spam requests to totally overwhelm your system, what we call a denial of service attack, or they might just poke around trying to find vulnerabilities right inside your code.
And this is exactly where the reverse proxy shines. Instead of the user talking directly to your application, they talk to Nginx. Nginx essentially stands at the front door like a bouncer, intercepting every single request. It can spot a spam attack, apply rate limiting to block someone who's clicking too fast, and only pass the safe, totally legitimate traffic through to your hidden backend. The client, they never even know the real address of your app.
This is a total game changer for engineering teams. Like the quote says, your developers get to just focus on writing code. They don't have to stress about building out all these security features from scratch. Because Nginx takes the hits at the front door, your coders don't need to be hardcore cybersecurity experts to implement rate limiting or block attacks.
Which brings us to tool number 4, the traffic cop, directing the traffic. Okay, so what happens when your app goes viral? What if 50 or, 5,000 legitimate users try to log in at the exact same millisecond? A single backend server is eventually going to tap out and get overwhelmed. You have to clone your application. You make multiple identical replicas, but once you have those copies, you desperately need a load balancer to act as a traffic cop, making sure one server doesn't get entirely crushed while the others are just sitting there twiddling their thumbs.
Nginx gives you some seriously smart rules to manage the chaos. Round robin strictly takes turns. Request 1 to server 1, request 2 to server 2, and so on. Then there's least connection, which intelligently routes traffic to whichever server is currently the least busy. And IP hash is fantastic. It creates a sticky session, basically guaranteeing that if a user comes back, they get routed to the exact same server they originally started on.
Oh, and you can get even more advanced.
You can do weight-based routing, so you could tell Nginx to send 60% of your traffic to your beefiest server and maybe just 40% to a smaller backup. You can even configure it to spot where a request is coming from and instantly route your VIP or premium customers to a completely dedicated, ultra-fast server replica while everyone else uses the regular ones. It's the ultimate way to prevent a single point of failure.
Finally, we reach our fifth and final tool, the armored car, sealing the envelope. So we've got the files, the security, the traffic routing all sorted out. But we have to make absolutely sure nobody can snoop on the data traveling across the internet between the user and your servers. We need encryption, specifically TLS or SSL. But again, we really don't want our developers coding complex encryption right into the app itself. By simply generating an SSL certificate and telling Nginx to listen on port 443, which is the standard for secure HTTPS, Nginx handles the whole shebang. It grabs the encrypted traffic, decrypts it right there at the gateway, and then forwards the clean, easy-to-read data locally to your hidden app.
This perfectly sums up the entire Nginx philosophy. The perimeter handles the armor. The application handles the logic. Nginx unpacks the armored car right at the gateway and hands a perfectly safe, normal, unencrypted package over the local network to your backend application. Your app just gets to do what it does best, processing business logic.
And that brings us to our final question to wrap up this explainer. When launching your next digital idea, are you just building a website or are you building a fortress? Because as we've seen today, the code you write is really only half the battle. Putting the right gateway in place, something that handles serving, protecting, balancing, and encrypting, that's what truly transforms a fragile piece of code into an unbreakable digital fortress. Thanks so much for joining me for this explainer, and I'll catch you in the next one.